Hello students, welcome to all my mentor math class. Students, as I can see, you guys are giving on my videos lots of love. Thank you so much for loving maths. Also students, I am adding one more thing that please comments on my videos so that we can be connected each other more frequently. If any doubts, anything, any problem, you can share with me, you can suggest me, you can write on your comment box on my videos. Okay, so let's start another very important problem with me. So students, today I am going to discuss about on the topic continuity. Okay, so that question already came in your JEE examination, JEE Mains examination 2023. So look at this question now. That is, let box x be the greatest integer less equal to x. Then the number of points in the interval minus 2, 1 where the function fx equal to box x mod of box x plus root under x minus box x is discontinuous is there are four options be given. Actually, what is the meaning of this question? So you have to find the number of points of discontinuity. Number of points of discontinuity. Okay, so the function is discontinuous for how many points you have to check out. Okay, so what is your given function? That is fx is equal to mod of box x plus root under x minus box x, and box x means the greatest integer is equal to x. And you know that continuity definition, analytical definition, continuity definition. What is your continuity definition? If fx is continuous at x equal to c, so that means you can write limit x tends to c, fx is equal to f of c. And limit exists means that is left hand limit, that is your limit x tends to c minus fx is equal to right hand limit, that is x tends to c plus fx, which is your right hand limit. If these two limits are equal, that means limit exists and limit x tends to c fx gives some value, and which is equal to f of c. If this condition satisfy, that means this function is, or any of the function is continuous. And but if the condition is not satisfied, that means this function is discontinuous. Okay, so let's going to next concept. Note please. Now you can see that box x function, fx is equal to mod box x plus root under x minus box x, and we have to work on the interval minus 2 to 1. We have to check on the interval minus 2 to 1. If I draw like that way, this is your minus 2, let us take this minus 1, 0 integers form. So you have to check, you have to work on this minus 2 to 1 interval, that is your open interval, so you can't take that boundary value also. So in between this interval, you see that there are two integers, one is your minus 1 and another is your 0. Okay, so look at this diagram also. So we work on this interval so that we can break the function as well as regarding your interval also. Okay, so if I take minus 2, you can see now minus 1 to 1 you can break like that way, minus 2 to minus 1 or closed one, this is closed in between, and this is also minus 1 to 0 closed, 1 to 0, and also you can break 0 to open 1. So we can break three parts for this interval, minus 2 to minus 1, minus 1 to 0, 0 to 1. So you can break this interval for your three parts. Okay, now we have to focus on that three intervals. So in that interval, what function behavior, what is the function in that particular interval? Okay, so now comes to here for minus 2 to minus 1, so fx is equal to, look at this, if I take that is your minus 1 in between minus 2 minus 1, whatever value you have to take, whatever value you have to take, let us take that is your minus 1.7, whatever value in between you have to take, that value gives, that box value gives is your, that is your minus 2. So mod of box value gives minus 2 plus root under x minus of this box value gives minus 2. And what is your question? From this expression you can think about that why we put here is minus 2, because if I take any point, let us take in between any point is your minus 1.7. If I take box function and it gives a positive greatest integer function, so that gives your that is your minus 2, it gives is your minus 2. That's why you put here minus 2 and root under x minus of minus 2. And next line, so next is your mod of minus 2, it gives positive value 2 plus root under x minus minus plus 2. So in that particular interval minus 1 to closed interval minus 1, the function value fx is equal to 2 plus root under x plus 2, because minus minus plus plus and mod of minus 2 gives 2. So note please. Next comes to your another interval, that is your closed interval minus 1 to 0. So for closed interval minus 1 to 0, you have to check the function fx. Okay, so fx is equal to, you see that the function is your mod x, mod of box x. So if I take in between any number, let us take minus 0.2. So that value gives is your minus 1. Let us take this is your open interval. Okay, so let us take this is your open interval. If I take in between this number, if I take minus 0.2, so it gives box of minus 0.2 is equal to minus 1. So that's why here you can put here, that is your minus 1, mod of minus 1, root under x minus this box x gives, if I take any values in between this interval, closed interval minus 1 to 0, so we get the value minus 1. So minus of minus 1, in that situation mod of minus 1 is your 1 plus x of minus minus plus 1. So you get the function gives fx is equal to 1 plus root x plus 1 in that particular interval. And lastly, you can see that particular interval, that is for closed interval 0 to open interval 1. Okay, so in that particular interval fx is equal to, if I take any value in between 0 to 1, let us take 0.1, 0.2, whatever value you have to take, the box function, let us take 0.3. If I take, so box of 0.3 gives 0 value, because this is your greatest integer function. So that whenever you put here, so in between 0 to open interval 1, so box x gives 0 value, so that mod of 0 plus root under x of minus of 0, so we get the value 0 plus root x, that means root x. So in that particular these three interval, so we can arrange, you can write like arrangement. Okay, so fx is equal to in your previous page I already see. So whenever minus 2 to minus 1, so that time function value gives 2 plus root under x plus 2, that means minus 2 less than x less equal to, that is your minus 1. Okay, and whenever comes to minus 1 to 0, that function gives 1 plus root under x plus 1 whenever minus 1 less equal to x less than 0. Okay, and finally you got root x value, and that time the interval gives 0 less equal to x less than 1. So this is the definition, this is the behavior of the function in that particular partition of the interval. Okay, now your job is, you have to check the function is continuous or is discontinuous at which point. So first of all look at this, you have to check the 2 points, you have to check on your 2 point, that is your 1 in between minus 2 to 0, there are 2 integers, minus 2 to 1, there are 2 integers, that is your 1 is your minus 1, 1 is your minus 1, and another is your, that is your 0. This is your minus 1 and this is your 0. So we have to check particularly 2 points, you have to check, and you have to check the discontinuity or continuity at that particular 2 points, that is your minus 1 and 0, because these 2 integers belongings to that open interval minus 2 to 1. Minus 2 to 1 in between these two integers. So that we have to check. First job, you have to check x at x is equal to minus 1. We have to check on that particular point. You have to check the behavior of the function, and also you have to check at x is equal to 0. So particular, if these 2 points, we have to check either function is continuous or discontinuous. Let's check. So first of all, so for x equal to minus 1, okay, so you can draw like that way. That is, let us take this is your x equal to minus 1, and so comes whenever you find check limit form, you know that what is the definition of limit. Limit x tends to c fx, f of x, or c plus f, or first left hand limit minus fx is equal to limit x tends to c plus fx is equal to fc. If this condition satisfied, that means function is continuous. If not, then function is discontinuous. So particular point is minus 1. Here c is your minus 1. First of all, check left hand side. Comes to first left hand limit. Left hand limit x tends to minus 1 minus fx. Okay, so comes to that way. So whatever value you have to take, that value is less than minus 1. And in that situation, what is your function value? If 1 less than 1, whatever value less than minus 1 means the function gives this function. A function gives 2 plus root under x plus 2. Okay, so you can put here, so limit x tends to minus 1 to the power minus, that is 2 plus root under x plus 2. Now you can put here minus 1, so that 2 plus root under minus 1 plus 2, so that we get root under, that is 1, so 2 plus 1, we got the value 3. So left hand limit value is 3 for that at that particular point if x is equal to minus 1. Note please. Now comes to your right hand limit. Now comes to your right hand limit for x equal to minus 1. Okay, so comes to here from right limit, you can comes to here. So right hand limit means whatever value you have to take, so that value obviously greater than minus 1 and close to minus 1. Whenever close to minus 1 means you have to take this function fx is equal to 1 plus root under x plus 1. That time we have to take this function, because close to whatever value you have to take for x equal to minus 1, close to minus 1. Obviously this is greater than minus 1, but close to minus 1 means in between minus 1 to 0 the function value is 1 plus root under x plus 1. So you can put here, so limit comes to right hand limit x tends to minus 1 plus fx, which is equal to limit x tends to minus 1 plus fx, means you can put here 1 plus root under x plus 1, and in that situation you have to put here minus 1. So root under minus 1 plus 1, that is 1 plus root 0, and you got your value 1. So clearly you see that left hand limit not equal to right hand limit. That means function fx is not continuous at x equal to minus 1. That means this is your discontinuity point, or discontinuous at your x minus 1. So function is your discontinuous at x equal to, so discontinuous at x equal to minus 1. So 1 point you got for discontinuity. Okay, so next you have to check for 0 value also, similar way. So copy please. Now for at x is equal to 0, we have to check. You can draw one like that way, x equal to 0, and at that particular point we have to check function is continuous or discontinuous. Okay, so now left hand limit you can find limit x tends to 0 negative fx. So now comes to this side. Okay, so whatever value we have to take, obviously less than 0, and that value close to 0. So whatever value gives x less than 0 means whenever x less than 0 means fx value obviously 1 plus root under x plus 1, because whatever value you take, that is obviously in between this, and that time the function gives 1 plus root x plus 1. So that means, so limit x tends to 0 minus fx means 1 plus root under x plus 1. So whenever I put here 0, so 1 plus 0 plus 1, that means 1 plus 1, which gives you 2 value. Okay, similarly you can find your right hand limit also. Limit x tends to 0 plus fx, that means it comes from right hand side and close to 0. So whatever value you have to take close to 0, obviously greater 0. So whenever greater 0 means in that situation function gives root x. So fx is equal to root x, because in between the function gives root x. So fx is equal to, we can put here limit x tends to 0 plus fx means root x, and it gives root 0, which is your 0. So clearly again you see that left limit is equal to 2, right limit is equal to 0. So both are not equal to, that means the function is your discontinuous. Okay, copy this. Now clearly you see that for x equal to 0, left limit not equal to right limit, so that it gives fx is not continuous. That means discontinuous at particular point x equal to 0. So you see that there are in between -2 to 1, there are two integers -1 and 0, and in both numbers, both points gives the function is discontinuous point, or that particular point the function is discontinuous. Okay, so you can see now fx is discontinuous at x equal to -1 and as well as x equal to 0 in between -2 to 1. Okay, so how many points for discontinuity? So there are 2 points for discontinuous. Okay, so which option is your correct? So option B is your correct option, and this is very nice question, similar type problem you can solve. Okay, so thank you. Next class we will again discuss.